Now let's take up the questions from the most interesting exercise, that is exercise 16, based on height and distances. Let's say question number 1. It says two ships are sailing in the sea on the two sides of a lighthouse. The angle of elevation of the top of the lighthouse is observed from the ships are 30 degree and 45 degree, right? So suppose the most important thing in the questions, height and distance questions, is the diagram, right? So let's draw the diagram like this. This is the lighthouse. These are the two sides. One ship is coming from, let's say, this side, and one ship is coming from this side. Now, on one side the angle is 30 degree and the other side the angle is 45 degree. Usually the lighthouse would be standing on the ground at an angle of 90 degree. Alright, so we have two right angle triangles. Let's call A, B as the lighthouse, C is one ship, D is one ship. Okay, now it's given that the height of the lighthouse is 100 meters. Wow. Okay, find the distance between the two ships. Let's say that this distance of one ship is x, the distance of the other ship is y. Now look at this carefully. Triangle ABC, that is a right angle triangle. Out of that, tan 30 degree must be equal to, opposite 30 is 100 and adjacent 30 degree is x. So from here we get 1 by root 3 is equal to 100 by x. So from here we get x is equal to 100 root 3 meters. Now root 3 value is 1.732, so multiply. So x is equal to 100 into 1.73. The value of root 3 is 1.73, so it is 173 meters. Right? Now on the other side, triangle ABD, you can directly say, because the angle is 45 degree, this is 90 degrees, so this is 45 degree. That means these two sides would be equal. So this side also must be equal to 100 meters. Okay, this they have already taken 173 meters. Or you can take tan value also. So triangle ABD, in that triangle tan 45 degree will be equal to 100 upon y, and we know that tan 45 degree is 1, so 1 equal to 100 upon y, so y equal to 100 meters. Alright, now the question is asking distance between ships. Distance between ships is equal to, distance between ships is equal to x plus y. So it is 173 plus 100, which is 273 meters approximately. Alright. Now let's take up question number 2. It says a man standing at a point P is watching the top of a tower. So let's say this is the ground, this is the tower, and from this point he is watching the top of the tower, and angle of elevation is 30 degree. Right? The man walks some distance towards the tower. So let's say he comes here now. Okay, and now he watches the top again, and now the angle of elevation becomes 60 degrees. So this angle is 60 degrees. Alright. Okay. Now what is the distance between the base of the tower and the point P? Now the base of the tower at point P. So this is P and this is the base. Let's call the base as B and this is A. Now here, because no value is given, at least one of the values should have been given. Because there is no values given, so all of them are variables. Let's say this is H, this is X, this is Y. Right? So the maximum that we can do is, we can say from the triangle, let's call this point as D. So from the triangle ABP, the maximum that we can do is tan 30 degree is equal to H upon, in the triangle ABP it will be BP. Right? Now tan 30 degree is 1 by root 3. So it is H upon BP is X plus Y. So this is one equation, that is X plus Y equal to H root 3. So we have three variables. We have got one equation. Now in the second case, let's say triangle ABD. In this triangle we have tan 60 degree can be taken as H upon BD. Now tan 60 degree is root 3 and H upon BD is X. So we have H is equal to X root 3. Now as you can see, we have only two equations but three variables. So this is not solvable. So the answer of this question is data inadequate. So in future, you can see that you don't have to draw the diagram even for this question. Just by reading, you can come to know that there is no possibility of calculation. The answer is data inadequate. Okay. But yes, if one of the values was given, you could have calculated the answer with the help of these two equations. Okay. I repeat, if one of the values was given out of h, x and y, if any one was given, you could have calculated the whole, all the values. Okay. Now let's take up the next question, question number 3. It says the angle of elevation of a ladder leaning against a wall is 60 degrees. So there is a wall and there is a ladder and the angle is 60 degree. Angle of elevation, so it is from top to bottom. From bottom to top, so it is 60 degrees, right? And the foot of the ladder is 4.6 meter away from the wall. So that means this distance is 4.6 meter. Let's say the length of the ladder is L and height of the wall is H. But we don't need height. We directly can calculate the length of the ladder. How? Let's see. We know sine theta, right? So in this given triangle, if you see sine, not sine, we have to use 4.6 meters. So let's assume cos. So let's take cos because adjacent side to 60 degree is known. So let's say cos 60 degree. Now look at 60 degree in the triangle. Adjacent side is 4.6 meters. Divide by hypotenuse, that is L. Now cos 60 degree is 1 by 2 is equal to 4.6 meters divided by L. So length is equal to 4.6 into 2. So it is 9.2 meters. So length of the ladder is 9.2 meters. Right? You could have also calculated the height of a wall. Let's do that. Just additionally height of wall. For that you would use tan 60 degree. Right? Now tan 60 degree will be opposite side, that is H, divided by base, that is 4.6. Now tan 60 degree is root 3, that is equal to H by 4.6. So H would have been equal to 4.6 root 3 meters or 4.6 into 1.73 meters, which is approximately equal to 7.96 meters. Alright. So if the height was asked, you could have calculated. Otherwise, the answer of this question is 9.2 meters. Okay. Now the next question, question number 4. An observer 1.6 meter tall is 203 meters away from the tower. The angle of elevation from his eye to the top of the tower is 30 degree. The height of the tower is, let's see, first draw the diagram. The very important step in all these questions is the diagram. Suppose this is the height of the tower. The man is standing here, right? His eye level would be like this, eyesight level would be this, and from here, when he looks at the top of the tower, the angle of elevation is 30 degree, right? This is 1.6 meter. Suppose the height of the tower is H. Now this length is 1.6 meters, so this also must be 1.6 meters. So the upper part would be H minus 1.6 meters. Alright, H minus 1.6 meters. Okay. Now this distance between the man and the tower is 203 meter. Okay, that means this length is also equal to I think there is a mistake. It is not 203 meters, it is 20 meters. One second, let's make the correction. It is 20 meters. So it is 20 meters. Alright. So this base length will also be 20 meters. Now apply the formula of tan theta in the triangle, in the upper triangle, that is right angle triangle, that will be written as, one second. So we have tan 30 degree can be written as 30, opposite side would be H minus 1.6 divided by 30, adjacent side would be 20, and value of tan 30 degree would be 1 by root 3. So it is H minus 1.6 upon 20. Okay. Now, so it becomes 20 by root 3 is equal to H minus 1.6. Here we have to calculate the value of H. Now 20 by root 3 can be written as, if you multiply by root 3 in numerator and denominator, you will get 20 root 3 upon 3. that is equal to h minus 1.6. Now 20 into root 3 will be 20 into 1.73 divided by 3, that is equal to h minus 1.6. So from here we get 20 into 173 would be 34.6. 34.6 divided by 3, and that is equal to h minus 1.6. Now 34.6 by 3 would be, if you divide it by 3, you will get 11.5, let's say 3, 11, 1.6, so it is 5 times, so 5, 3 is equal to h minus 1.6. So h is equal to 11.53 plus 1.6, which is 11 and 1, 12, 13.13 meters. This is the answer of this question. Alright, so you can look for the correct option. I think it should be none of these. Okay. Now let's move on to the next question, question number 5. It says from a point P on a level ground, the angle of elevation of the top of the tower is 30 degree, right? So it's a simple question. The top of the tower is 30 degrees. So this is 30 degree angle. The tower is 100 meter high. Alright, tower is 100 meter high. We have to find the distance of point P from the foot of the tower. Let's say it is F. Let's say this is X meter. So straight away we see that tan 30 degree is equal to 100 upon opposite side upon adjacent side, 100 upon X. Now tan 30 degree is 1 by root 3. It is equal to 100 upon X. So from here we get X equal to 100 root 3. Now value of root 3 is 1.73. So 100 into 1.73, which is 173 meters. So this is the required value of X, or this is the distance of P from foot of the tower, 173 meters. Question number 6. The ratio of length of a rod and its shadow is 1 is to root 3. So that means a rod is standing like this and its shadow is on the ground, right? So let's say length of the rod is H and this shadow is S, right? And let's complete this triangle. Now this means wherever the light of source of light, this is suppose the source of light, this is angle theta at the elevation of the source of light is at the angle of elevation of the sun, right? That is theta. Theta is the angle of elevation of the sun. Okay. So from here very clearly we can see that tan theta is equal to H upon S. And it's already given that the length of the rod, that is H, and shadow are in the ratio 1 upon root 3. Now we know that 1 upon root 3 is tan 30 degree. So very clearly theta is equal to 30 degree. So the angle of elevation of the sun in this case is straight away 30 degree. So even you don't need to draw the diagram. If you know that the ratio is 1 is to root 3, straight away the angle of elevation of the sun would be 30 degree, right? Similarly, it says seventh question is almost the same question. It says the angle of elevation of a moon when the length of the shadow of a pole. So let's say this is the pole and this is the shadow. Suppose the length of the pole is H and the length of shadow is S. And here is the moon, right? Suppose this angle is theta. So we have tan theta is equal to H upon S. And in the question it says the length of the shadow of the pole is equal to height. So H is equal to S. So what will happen? If H is equal to S, then H by S will become equal to 1. Now tan theta equal to 1. Now 1 is equal to tan 45 degrees. So very clearly theta has to be equal to 45 degrees. So for all questions of shadow, right, you can apply this formula or this method, right? Tan theta is equal to height of the tree, pole, whatever it is, right? And divide by the shadow of that thing. So you will get that angle as angle of elevation of the source of light, whether it is sun or moon. Now let's take up the next question, question number 8. It says in a rectangle, if the angle between a diagonal and its side is 30 degrees. So let's draw a rectangle. Let's draw a diagonal. Now in a rectangle, the angle is, this angle is 90 degree, right? And it says the angle between a diagonal and a side is 30 degree, right? So let's say this angle is 30 degree. And the diagonal length is 6 centimeters. 6 centimeters. Let's say this is A side and this is B side. From here, we have to calculate the area of rectangle. Now, to calculate area, we need the values of A and B. So what do we do now? The hypotenuse length is given. So we'll apply, let's say, sine 30 degree. Whenever a hypotenuse is given, you have to use either sine or cos. So sine 30 degree from this triangle would be equal to B divided by 6, opposite side divided by hypotenuse. And we know that sine 30 degree is 1 by 2. So 1 by 2 is equal to B by 6. So this gives us B equal to 6 by 2, that is 3 units or 3 centimeters. Similarly, cos 30 degree will be equal to adjacent side, that is A, divided by hypotenuse, that is 6. So from here we know that cos 30 degrees root 3 by 2, that is equal to A by 6. So 2 cancels 6 3 times. So A is equal to 3 root 3 centimeters. So this gives us the area of rectangle, which is equal to A into B, which is equal to 3 root 3 into 3. Now 3 root 3 into 3 is 9 root 3 centimeter square. This is the required area of the rectangle. Alright. Now let's take ninth question. On the level ground, the angle of elevation of a tower is 30 degree. So let's say this is ground, this is tower, and this angle is 30 degree. On moving 20 meters nearer, the angle of elevation is 60 degree. So we move towards the tower, right? And we have moved, let's say, 20 meters, and then the angle of elevation is 60 degree. Alright, so if I name the triangles as A, B, C, D. Suppose the height of the tower is H and the distance BC is X. Alright, so what we have to do is we can calculate, let's see, from the triangle ABC, tan 60 degree would be equal to opposite side H upon the base X. Now this gives us tan 60 degrees root 3 is equal to H upon X. So from here we need to calculate height. So let's calculate X. So from here we get X equal to H upon root 3. Let it be like this. X is equal to H upon root 3. Now from the triangle ABD, tan 30 degree is equal to opposite side, that is H, divided by the whole base. Base will be BD. So let me write one more step. Now H by BD would be H by X plus 20. Now tan 30 degree is 1 by root 3, that is equal to H upon X plus 20. Now if you cross multiply, you will get X plus 20 equal to H root 3. Alright. Now X we have already calculated as H by 3. So put it in this equation, you will get H by root 3 plus 20 equal to H root 3. So from here we get 20 is equal to H root 3 minus H by root 3. So take LCM as root 3, you will get 3H minus H, and that will be 2H upon root 3. So 20 is equal to 2H upon root 3. So 2 cancels 20 10 times, and we have H is equal to 10 root 3 meters. Alright, so this is the final answer of this question. 10 root 3 meters. Alright, so this is the final answer of this question. Now let's take question number 10. It says a person of height 2 meter wants to get a fruit which is on a tree of height 10 by 3 meters. Okay. So, and if it stands at a distance of 4 by root 3 meters from the foot of the tree, then the angle at which he should throw the stone so that it hits the fruit is. So let's say this is the ground, this is the tree, this is the position of fruit. Alright. Now the person is standing here, his height is 2 meters, right? His eyesight is this level. Now if this is 2 meters, then this length should also be 2 meters. So this is 2 meters. The distance of the man from the foot of the tree is 4 by root 3 meters. So this length is also 4 by root 3 meters. This length is 4 by root 3 meters. Now let's join this. So this angle must be equal to theta. Let's assume this angle is theta. Now the total height of the tree is given 10 by 3 meters. So this height will be 10 by 3 minus 2. Alright. Now from the triangle, right angle triangle, we have tan theta equal to 10 by 3 minus 2, that is opposite side, whole divided by 4 by root 3. Now if you simplify this, you will get tan theta equal to, now 10 by 3 minus 2 will become 4 by 3, and whole divided by, denominator is 4 by root 3. So 4 and 4 get cancelled. We will have root 3 by 3, and that is equal to 1 by root 3. So we have tan theta equal to 1 by root 3, and we know that 1 by root 3 is equal to tan 30 degree. So from here we can say that theta is equal to 30 degree, and that is the answer of this question.